Hello. Today, let me walk you through top k frequent elements problem in around 25 minutes. Okay, let's start. So, given an integer array nums and an integer k returns a k most frequent elements within the array. The test cases are generated such that the answer is always unique, and you may return the output in any order. Okay. Let's understand this problem. So first, we can ask to interviewer question. What are the constraints on nums and input k? Okay. After later, we explain constraints part. And next question, what should we return if the ranks of nums are less than k? For example, nums equal only 1 and k equal 2. It's impossible. K is less and equal than the ranks of nums. Okay, and later we can confirm constraints phrase again. And next, if k is 0, what should we return? Because top 0 frequent element, what does it mean? It's impossible. So k is greater and equal than 1. Okay, let's think about copy case. Nums equal 1, 2, 2, 3, 3, 3. And k equal 2. So then, in this case, 3 is most frequent. Oh, it's very thick. Now, 3 is most frequent element. So top 1 most frequent. And second is 2. So we return 3 and 2. This is in any order. And edge case, nums or just only 1 and k equal 1, we can return only 1. Okay, let's move on constraints. K is starting at 1 and at most ranks of nums. So in this happy case, this ranks of nums equal 6. So k at most 6. And next, nums I equals starting at minus 1000 and up to until 1000, positive 1000. And ranks of nums is minimum at least 1 and at most 10,000. Okay, so this understanding and match phase is over. Next, let's move on plan. Now, maybe 5 minutes or 4 minutes. Yeah. Let's think about plan. If we try to solve this problem in a straightforward way, we can use brute force. First, we have to count, because this problem we find the case most frequent elements. So we have to count the elements, the frequency of elements. And if we hear the count, we can use hash map. Today, my finger is not working, so sorry. And if we count input nums as a frequency of nums, and sorting the unique elements by sorting unique elements by frequency in descending order and return the first k elements. So in this case, 1, 2, 2, 3, 3, 3, we count this. So 1 is, sorry, 1 is 1 because 1 appears only once, and 2 is 2, 3 is 3. This is element 1, 2, 3, and this is count once, twice, 3 times, and sorting and descending order. So this map is 3, 3, and 2, 2, and 1, 1. And we take first 2 elements. So we can return 3, 2 is result list. This is brute force plan, but let's check this complexity. We use sorting, so this works big O n log n time complexity. It's good, but maybe we can solve this problem more efficiently, more better approach. For example, big O n linear time. More better approach. Okay, so next, another approach. Sorry, this is brute force plan. And next is another plan is bucket sort approach. Bucket sort approach. What's this? In this case, also we count frequency of elements. This is same with brute force approach. But build in this approach, in this case, we can build a frequency bucket. Frequency bucket. What's mean? This is create an array freq of size n+1. So this is like this. Freq is this is array. So let's image happy case nums equal 1, 2, 2, 3, 3, 3. In this case, this nums length is 6. So we can build a frequent array. The size is n+1, so 7. So 1, 2, 3, 4, 5, 6, 7. Why? Because put each number into this frequent array, and this frequent array, the index represents frequency. So this is 0, 1, 2, 3, 4, 5, 6. And you know, nums length is 6. So maximum k is also 6. Maximum k is also 6. And frequency is also maximum 6. What's mean? Nums length is 6. So at most 3, 3, 3, 3, 3, 3. So in this case, the frequency is 6 because 6 times 3 appears. And this frequency array, and in this index represents frequency. So if 333, 333, we can use here 3. If this case 1, 2, 2, 3, 3, 3, we can use this like this. So index 1. So frequency is 1, so we put 1. And frequency 2 times appears, so we put here, and of course this. And we look go down order and descending order. We take top k element, and we return this. This is read from right to left. Iterate from index 6 to 0 and correct numbers until we have k elements. Mm. We have we have 10 minutes rest. Okay, let's write a pseudocode. Pseudocode. First, we prepare count, frequency hash map. And frequency array is array of n plus one size empty lists. And we can make frequency array. We can put an element in the frequency array. So for loop, we can count hash map, and we put frequent array, count num and num. And of course, we have to prepare result list. And we iterate we iterate a frequent array. So for loop n down to 1, and we have to next loop because so let's image this example. 2, 2, 3, 3, and k equal 1. In this case, we put 2 and 3. So this size is 4, so we prepare size 5 frequent array and index 0, 1, 2. So we put 2 and 3 here. So we have to loop this sublist. Okay, let's back. Return to here, and we have to loop index I. So nested loop, and result list, we add append. We append num And if ranks result equal k, then we return result. Okay, that's all. This is pseudocode. So let's jump into the implement Python code. Copy and wow. Mm, 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 mm. No. Mm, okay, here. Not pseudocode, Python code. First, mm, we have to use class solution. Okay, yeah, solution top k. Good. Top k frequent and self list nums k, and we return result. First, we have to prepare hash map. Of course, we can use a collection count and default dictionary, but now we have to practice more common way and more. If we use another programming language, we can write like this. And next, frequent array. In Python, we can use this way of writing for I in ranks of num plus plus 1. Sorry. Yesterday, I bought a new US keyboard. So far, I used uh, J, uh, Japanese keyboard. So I'm mm, I'm not I have I have not get used to I not get used to US keyboard. So okay, let's restart. And frequent. We define the frequent array. Yeah. So we have to loop for n in nums n in nums. Count n equal 1 plus count get n, or default otherwise 0. Time up. Maybe more than 5 minutes extend. Count get n, otherwise 0. And we have to prepare result. And not enough to make a frequent array. For n c in count dot items, and c in count dot items frequent c dot append n. So this sentence, this line means put the corresponding index box, put the element corresponding index box. So this is here. And we prepare result, and for I in range, this is reverse order. So when frequency array minus 1 and 1 to so last index to 0 and reverse order, so -1. And nested loop, here is this, the same index box. We have to loop these elements for n in frequent I, result dot append n, and if len result equal k, return less. Okay, let's check this answer and let's running. Last review. So count, this is hash map, and we prepare frequent array. This is empty. This is still empty list, and we iterate nums, and count n equal 1 plus count dot get n, default 0. So this line is creating a count hash map. And next loop, this is nc. We iterate the count items, count values, and frequent c, index c, and we append n in this box, in this index box. So these two line represents creating a frequency array and result list and range len freq -1 to 0. So last two start and -1. So this represents reverse order. And this loop is the same frequency. Sorry, it's time over. This loop represents the same frequency elements we iterate and less append n. If we find the number of if we find a k unique elements, we finish this loop. That's over. No need to scan the whole array. This approach takes linear time complexity because this loop and this loop and this loop is maximum we iterate n loops. But this is nested loop. But for this is nested loop, but length frequency -1 to 0. So this is n time loops. And but this is not n loops because maximum okay, let's running. Oh, why? For freq is for I in range lengths. Oh, huh? Num. Sorry, nums. Answer nums. Freak. Okay. So that's all. Thank you for watching.